So the first question they are asking for, which option contains a fundamental SI unit and an SI supplementary unit? So there are 7 fundamental units and 2 supplementary units. So using those 7 units, we can measure, we have 7 fundamental quantities: length, time, mass, electric current, thermodynamic temperature, luminous intensity, and amount of substance. So to measure those 7 fundamental quantities, we have meter for length, then seconds for time, then we have kilogram for mass, then we have ampere for electric current, then Kelvin, this is a capital K, to measure thermodynamic temperature, then candela to measure the luminous intensity, and mole to measure the amount of substance. So these two are in capital letters because they are named after scientists. So these are the 7 fundamental units. So besides that, we have 2 supplementary units. Those are radian, RAD, simple RAD, then steradian, SR. So radian is used to measure the plane angle, then steradian is used to measure the solid angle. So if you look through the options given, so fundamental quantity, so if you think about a second option, Kelvin, that's a fundamental unit, then we have steradian, which is units are simple S, simple R. So the option should be the second one, the correct one, Kelvin and steradians. Other units are some derived units. And second question, dimensions of power is. So for this, you have to remember the equation for power. Power is work divided by time. Or in other words, it is a rate of doing work. Just remember the easy equation to get dimensions of work first. Work, W, it is equal to force times distance. So force, dimensions of force is ml 2 minus 2. Distance, capital L. So we simplify that, ml is square t minus 2. So this is the dimensions of work. So I'll substitute it here, ml square t minus 2. Then divide it by the time. Then you get ml square t minus 3. So this is the dimensions of power. So the answer should be the 4th one for the second question. Okay, then we have a third question. It's a question about Vernier caliper. 49 millimeter length of a main scale is divided into 50 parts. The measurement shown by it is 6.048 centimeters. Number of vernier parts that coincides with for this measurement is. So they say using this vernier caliper they have measured a length that is equal to 6.048 centimeters. I will write this in millimeters. To convert this into millimeters, just multiply this by 10. So this will be 60.48 millimeters. So 1 centimeter is a 10 millimeter. That's why I multiplied by 10. So this part, 60 millimeters, can be measured using the main scale. Main scale. This decimal part, this is 0.48. We have to use the Vernier scale to measure this. Vernier scale. So here they are asking the number of vernier parts that coincide with this measurement, meaning that relates to this length, meaning that is 0.48 millimeters. First, we have to calculate. Before this, we have to calculate the least count of this measuring instrument. So the least count, as I have explained in a previous test, least count is equal to length of one division of main scale. So in this case, length of one division is 1 millimeter. Then the length of one vernier scale division is, according to this one, 49 millimeter of main scale length. 49 millimeter of length is divided into 50 vernier scale parts. So if you divide it by 50, 49 divided by 50 millimeters is the length of one vernier division. So this is least count equals length of one main scale division minus length of one vernier scale division. So 49 divided by 50 is 1. That is how you can find length of one vernier scale division. So to simplify this, 50 minus 49 millimeters, 1 over 50 millimeters. So the answer should be 0.2. If you divide 1 by 5, it is 0.2. Again, you have to divide by 10. 0.05 millimeters. So this is the least count that can be measured using the vernier scale. So this is not what they ask. What they ask is the number of vernier scale divisions or vernier scale parts that makes this length 0.48 millimeters. So to find that, you just have to divide that 0.48 millimeter length by the least count. Then you can get number of vernier scale parts. So this is 1 over 50. 0.48 times this is 1 over 50. Sorry, here it should be 1 over 1 over 5 is 0.2. So again divided by 0, then it becomes 0.02. So that's an error with the calculation. This one should be 0.02. This should be 0.02. So 48 divided by 2, that is equal to 24. So this is 24. There are 24 vernier scale divisions that needs to be coincided with the main scale division in order to show this 0.48 millimeter length. So you have to remember, this is the measurement. This part can be read by using the main scale. To get this, we need the vernier scale. So the answer for that question should be third one. The fourth question. Pitch of a screw gauge is 0.5 millimeters and its circular scale is divided into 500 parts. So they are asking for the least count of the apparatus. So you have to remember how to find the least count of a screw gauge apparatus. So least count of a screw gauge can be measured using this equation. Pitch divided by number of circular number of divisions in circular scale. So if I remind you, this is the screw in the apparatus. So this length is what we call pitch. Then there's a circular scale above it. Then this circular scale is divided into like the required number of parts. Here it is divided into 500 parts. So if I rotate this a little bit, let's say like one part, then the screw goes into or out of the paper, out of the apparatus. It moves vertically equal to a least count of that screw gauge. So using this one, pitch divided by number of divisions in circular circle, we can find the least count of a screw gauge. So here the pitch is, they say, 0.5 millimeters. So it is a half of a millimeter, that's the length of the pitch. Just divide into 500 divisions in circular scale. 100, 0.1, and 0.1 divided by 100 is 0.001 millimeters. So this is 0.1001 millimeters. So using this apparatus, we can measure the least count. The least count of this is 1,000th of a millimeter. That is 0.01 millimeter. So the answer should be fifth one for the fourth question. Okay, moving on to the next question. Fifth question regarding a linear motion. A car moving at constant acceleration takes 5 seconds to move between 2 points at a gap 15 meters. So gap is 15 meters and it has a constant acceleration. Let's say the acceleration as simple A. If the velocity of car when it passes second point is 5 meters per second, so the second point, the speed of the car at that point is 5 meters per second. So they are asking for the velocity at the first point. Let's say that is u. So it's an easy question. You just have to apply. They haven't given an acceleration. Yeah, they haven't given the acceleration, but they have given time. So for this motion, it takes 5 seconds. So you have to use like one equation in order to get like quickly the answer. So without finding the acceleration, we have this equation. S equals u plus v divided by 2 times time. So using this one, you can find u. So here displacement is 15 meters, then u plus v is 5 divided by 2 times time is 5 seconds. So I'll cancel this 3, then this is cross multiply, then this is 6 equals u plus 5. The u is equal to 1 meters per second. So this is the initial velocity. What I just did is I applied this equation from here to here. So the answer should be second one for the fifth question. Okay, next question, sixth question. Velocity gained and time required for an object released from a height 3.2 meters from the ground is. So they are asking the velocity as it reaches the ground, right? So they release the object at a height 3.2 meters. Release the object means initial velocity at that height is 0. 3.2 meters. They are asking for velocity gained and time required for this motion. So let's say the velocity here is v. This falls under gravity, so g equals 10 meters per square second downwards. So just apply this equation, v squared u squared plus 2s. So in order, you have to choose the best equation. I mean, in order to save time, right? You can simplify use. You can use other equations like 2 or 3 times. But in order to save, you have to have the practice to apply this equation at once to get the answer. Okay, then v squared, u squared is 0 plus 2, acceleration 10, distance is 3.2. 3.2 times 10, 32, 30 times 2, 64. V v squared equals 64, then v is equal to, take the root. So I remember the root of 64 is 8. So the answer should be 8 meters per second. That's the velocity of the object as it reaches the ground. Then they're asking for the time that motion takes. Again, you would just apply this equation, v equals u plus 80. So we know the final velocity, that is 8. Initial velocity 0 plus acceleration 10 downwards, then t. Then 10t equals 8, meaning 0.8 seconds. So that is the time required for this to reach the ground. So the answer should be the third one, 80 meters per second and 0.8 seconds. Okay, seventh question. A man with a parachute free falls for 10 seconds. Free falls means he is falling under gravity at acceleration 10 meters per square second. So let's say he's dropped off from the plane at this position, at this height. And for 10 seconds he free falls. Meaning that acceleration is under gravity only. So is under gravitational acceleration. Then for 5 seconds, deceleration of 5 meters per square second. So I can show that here the acceleration, meaning for 5 seconds acceleration is actually upwards, but it is moving downwards. Since it is a deceleration, we can mark the acceleration upward within this 5 second time period. So what they ask is 5 seconds for 16 seconds. 5 meters per second for 16 seconds, not 5 seconds. Deceleration is 5. Time period is 16 seconds. So what they ask is this total height that is dropped off from the plane. Since within these two, from AB to BC, it is not the same acceleration. So we have to apply equations separately for those AB and BC. So first, initial velocity is 0. Initial velocity is 0. Then you need to get the velocity at B. I think this is like the easiest way to find this. So I'm applying equations from A to B. First, I'll find the speed at B using this. The speed at B, right? Initial velocity at A is 0. Then this is gravitational acceleration 10. Time is 10 seconds. So this is 100 meters per second. As it reaches to point B, velocity is 100 meters per second. This is the velocity. It will be easier if you found the velocities at these points. Okay, then I'll find this distance. That distance means AB. So for that, I'll simply use this one. I think this is easier. S equals U plus V divided by 2 times T. U is 0, V means this here, right? Still we are applying equations between A and B. V is 100 divided by 2, time taken is 10. So 5 times 100 is 500 meters. So that is the distance between A and B. Still we have to find the distance between B and C. So for that, first I'll find speed at C. For that, again, between B and C, I'll apply V equals U plus 80 downwards. So this is the initial velocity now between B and C. Velocity here is the final velocity. So we don't know that. I put v there. So initial velocity is 100. It is downwards. This acceleration is upwards, right? Because this is a deceleration. So I put a minus 5 here. Then the time is given as 16. So 100 minus 5 times 16, 80. 100 minus 80 is 20. It is not a negative velocity, so it confirms that there is still a velocity. It's downwards here. The value is 20 meters per second. Okay. So now we know the velocities at B and velocities at C and the time between those 2 points. Then I can apply between B and C. We need to find the length, distance, using this equation. Initial velocity is 100. Here the velocity is 20. Divided by 2 times the time is 16. So this is 8. 120 times 8. So 120 times 8 is, I think, 960 meters. 960 meters. So this is the distance between B and C. So in order to find the total distance from A to C, you just have to add these two. So 500 and 960. 0640. So this is the total distance that the man moved as it reaches the ground from the plane. So the answer should be the fifth one, that is 1460 for the 7th question. The 8th question, the ball is projected vertically upwards. Which one of the quantities remains constant for its motion? Okay, so they say a ball is projected upwards, so the motion of it would be like this. Goes up and comes down along the same line. These are not two lines, right? These two lines coincide. Then, so they are asking what remains constant for this motion. So you know that as the object goes up and comes down, the displacement constantly varies. The speed also constantly varies. Here the maximum speed is speed 0, then again maximum speed. In between, the speed has between values. The kinetic energy, that is half mv squared, since the speed changes, that also changes. Then we have acceleration, then the velocity also changes because the speed change. But acceleration here remains a constant. Why is that? So when they say acceleration, you always have to think in terms of the unbalanced force acting on that. It is hard to think about acceleration at once because it is a bit complicated to think about acceleration. But force is very comprehensible. Net force. So whenever you have to think about acceleration, think that in terms of force. Because force is at ma. So this force and acceleration are the same, similar quantities. Only difference is acceleration is just multiplied by a constant, which is mass of the object. So these force and acceleration have similar behaviors. So whenever they ask something about an acceleration of an object, think about the unbalanced force acting on the object. Here, what is the force acting on the object while it is moving up and down? The only force acting is mg downwards, regardless of object goes up or down, regardless of the direction of the object moving. As it goes up and as it comes down and as it at the top, always the force acting on that is mg downwards, meaning acceleration of the object all the time should be downwards and it is equal to gravitational acceleration, which is 10 meters per square second. So for some students, you may think, some mistakenly think that acceleration here is zero at the top, because of velocity, they think acceleration in terms of velocity. Velocity at the top is zero, but acceleration at the top, still there's that unbalanced force acting on that. So the acceleration is 10. It doesn't change. It is always 10 downwards, whether the object goes up or down. That's why you need to think about acceleration in terms of unbalanced force acting on the object. So the answer should be fourth one for the 8th question. Okay, then the 9th question. Horizontal distance, an object projected horizontally with a u from a height h moves when it hits the ground. Okay, so this is a question about a projectile. So the object is given a velocity that is horizontal. That velocity is u. So it reaches the ground in a projectile motion. Acceleration downwards, it is just gravitational acceleration. That is the only acceleration acting on the object. Initial velocity, it only has a horizontal initial velocity. Vertical component downwards is actually zero. Right? There's no initial vertical component. It is zero. So they are asking for this distance, simple x. Then this height is given as simple h. So first apply equation vertically downwards. So ut plus half at squared. Displacement is h. U is 0 because vertically downwards initial component is 0 here. Right? So this term becomes 0 plus half gravitational acceleration g t squared. Then we need to find time actually for the object to go from here to here, because that is the same time that the object takes to move along this parabolic path. 2g divided by g t squared, then t is equal to 2h over g. This is the time taken for this motion. So what they ask is a simple x. We just apply s equals ut plus half a squared horizontally. So this direction is x. Then the velocity to this direction is u. Time t. I'll substitute that time with what we just found here. That is 2h divided by g plus, there's no acceleration horizontally, right? I mean, there's no force acting on the object horizontal direction. So there's no acceleration, so it is 0. So the answer should be u 2h divided by g. So the answer should be third answer for the 9th question. Okay, 10th question, a question about relative motion. They're asking us maximum relative velocity between two objects is 100 meters per second. Minimum relative velocity between them is 20 meters per second. So they're asking for the velocities. The velocities of each object, meaning relative to Earth. If they don't mention that, it means those velocities, what they ask is relative to Earth velocities. So I'll say velocity of first object, I'll take it as v1, and second object v2. First object, second object. So we know that relative velocity, so they have certain speed. So if the relative velocity to be maximum between the objects, they should come face to face, right? So that is how you can experience the maximum relative velocity. That is when you see the fastest that the other object reaches towards you. So this is v1 plus v2. So now they are moving to opposite directions. So the relative velocity between them should be v1 plus v2. So the relative velocity, they say that it is equal to 100. For the minimum relative velocity, objects should move to the same direction. So these are explained in the theories, right? So for that, we need like this, v1, then v2. Objects should be moving to the same direction. Then for the same direction, relative velocity between the objects is the difference between their actual velocities. That is v1 minus v2. That is the difference. So they say that it is equal to 20. So simply, this is the first equation, then this is the second equation, this is the simultaneous equations. Simplify them and you can find v1 and v2. Those are the velocities that are relative to Earth. So simply add them, then v2 cancels off. v1, 2v1 equals 100 plus 20, 120. Then v1 divided by 120 divided by v2. So that is 60 meters per second. 60 meters per second, that is v1. Then I can substitute this v1 in the first equation or the second equation. I substitute it in first equation. v1 plus v2 equals 100. Here the v1 is 60. So v2 should be 100 minus 60, that is 40 meters per second. So one velocity is 60, then the other velocity is 40. Right? So if they are moving to opposite directions at 60 and 40 meters per second, then the relative velocity between them should be 100 meters per second. If they are moving to the same direction, then the relative velocity between them should be 20. So these two answers are valid there, right? Yeah. So the answer should be fourth one for the 10th question. Okay, moving on the 11th question. A mass M is incident on a wall at V at an angle 45 degrees with a wall. So let's say this is the wall. A mass, simple M, is incident on the wall making angle 45 degrees. Then let's say mass bounces off the wall at the same speed, meaning V, making the same angle but to the other side. So still the angle is 45 degrees and the speed is V. So this is the wall. It bounces off like this. So let's say that if n number of molecules is in molecules, so the mass of a molecule, that is simple M. On the wall within a second, they are asking for the force applied on wall. So if you remember, the force is, the unbalanced force is equal to the rate of change of momentum. So first we'll find the change of momentum for a one collision. So I'll explain this change of momentum. I'll say that delta P, right? Delta P for one collision. So first, that is what we are going to find. So for that, I need to resolve these are momentums into normal to the wall and parallel to the wall. So if I'll first resolve this vector. Okay, for this vector to the normal to the wall, that is, I can say mv cos theta, mv cos theta. Then parallel to the wall, this is the wall, parallel to the wall is I can say mv sine 45. Angle is given, so it is 45. Then the next vector, that is this mv, right? That is the final momentum. So if I get the if I resolve that normal to the wall, that becomes mv cos 45. Then parallel to the wall, that is mv sine 45. So in order to find delta p, so what is delta p? This is for one collision. Okay, that is final momentum minus initial momentum. So final momentum means this momentum. Initial momentum is this one. I mean, this momentum, it is before collision. This is after collision. You can think that like that as well. After collision, this is the momentum. This is before collision. Then I resolve this. Right? Okay, so what you have to do is I just have to subtract from these and from these and these. So if you subtract this vector minus this one vector. So these are the same vectors, right? They are like equal vectors, their direction also the same. So that's why there's equal vectors. So if you subtract these two gets cancelled off. So along the wall, the momentum, there's no momentum, net momentum. But here, final momentum component is cos 45 to this side minus initial momentum is mv cos 45 to the other direction. mv cos 45 to this direction. I can change the sign and draw the arrow to the other side, opposite direction. So this becomes minus, minus, minus becomes plus. Then you can add these two vectors. Okay? I think you are familiar with those vector calculations. Then this is 2mv cos 45. 2mv cos 45 is 1 over root 2. So 2 means root 2 times root 2. So you can cancel one of the root 2, then this becomes root 2 mv. So this is for one collision. This is the rate of, not rate, the change of momentum for one collision, like this. Then they say n number of collisions causes on the wall per second. Per second means that is going to be a rate. So the force due to these collisions should be root 2 mv times simple n. This is for one collision, this is for n number of collision. Since it is given per second, this also becomes, if you multiply that, this becomes a rate. So this is rate of change of momentum for n number of collisions, like this. So the answer should be root 2 mv n. So that is the rate of change of momentum or the force. So the answer for that should be second one for the 11th question. They say given that a resistive force acting on a vehicle with mass 800 kg is 400 newtons. Mass of the vehicle, that is 800. And there's a resistive force, meaning that if the vehicle moving to this side, the resistive force acting opposite side, that is 400 Newton. So what they ask is driving force required to accelerate. So let's say the driving force required is like P or something. So they say that vehicle needs to be accelerated from 10 meters per second to 20 meters per second within 5 seconds. So simply you can find the rate of increase of velocity. Okay, first I find the acceleration. Acceleration is change of velocity divided by time. Change of velocity is 20 minus 10 divided by time is 5. So 10 divided by 5 means 2 meters per square second. So that is the acceleration of the vehicle. First I found that. Then simply apply F equals ma horizontally to the vehicle. So that is P minus 400 equals 800 times acceleration we found, that is 2. So P equals 400 plus 1000. 800 times 2, 1600. And this becomes 2000 newtons. So 2000 newtons is the driving force of the vehicle. So the answer should be third one for the 12th question. Next, moving on 13th question. From a coconut tree with height 5 meters. So the height of the coconut tree, that is 5 meters. Coconut weighing 500 grams. So that is 0.5 kilograms. Falls onto the ground. Let's say this is the coconut. So the mass of it is 0.5 kilogram. It penetrates the ground to a distance 25 centimeters. So when they say due to that impact with the ground, it penetrates through the ground to a distance 25 centimeters. So it is convert that into meters. Meters means 0.25 meters, 25 centimeters. It is divided by 100, right? 0.25 meters. So then it stops here. Doesn't further penetrate, so it has to stop here. So what they ask is resistive force acted by the ground on the coconut as it penetrates. So as it penetrates, there should be a resistive force acting on the coconut, slowing it down. So it would stop here. Otherwise it keeps penetrating, right? So there must be a resistive force acting by the ground as it penetrates, right? It is not applied here. Here it is only gravitational. It is only force acting is weight of the coconut. But here, as it penetrates the ground, there is a weight of the coconut and resistive force. Okay, so this is what they ask. I've solved this into two parts. As it falls under gravity and as it penetrates the ground. I'll say like from A, B, C. So those are the levels, A, B and C. Okay. For this, I'll find the velocity of the coconut as it hits the ground. So for that, force under gravity 10 meters per second. I'll apply this one. It is from A to B. U plus 2as. Because the time is not given. So this is the only equation without the time for linear motion. So V squared that is final velocity at B, velocity at B. U is, it is released from the coconut tree. So it is 0 to 10 acceleration. The distance it falls is 5 meters. So this is 100. V squared 100, V means 10 meters per second. It is the velocity here. 10 meters per second. We found that first. So in order to find this resistive force, I'll apply Newton's laws, F equals ma. So to find resistive force, first we need to figure out the deceleration caused by the ground. Deceleration of the coconut tree inside the ground. So for that as well, I will apply the linear motion equation. But that is applied from B to C. I'll apply this one. So the final velocity here, since it stops 0, initial velocity at B, that is 10, plus 2, 10 square plus 2, I will say the axial deceleration inside the ground is simple F. And the distance it moves is 0.25 meters. That is the penetrated distance, 0.25. So this is 100. I'll take this term to this side. Then this becomes negative. 2f times 0.25 means 1/4. So just have to simplify this. 2, cross multiply, it becomes minus 200 meters per square second. So this is like a huge deceleration, right? 200 meters per square second. This is like 20 times the gravitational acceleration. It's a huge deceleration, right? 200 meters per square second. As you can see, it is actually an acceleration upwards. Okay, then I'm going to apply F equals ma. That also for B, between B and C. Okay, so what are the forces acting now on the coconut inside the ground? Mg and resistive force. And the acceleration we found 200 meters per square second upwards. So I apply the equation downwards. You can apply the equation in any direction. So I apply that downwards. Here it is mg. Downwards. F is upwards, so it is minus f. Mass acceleration is upwards. So here you have to substitute it as a negative acceleration because equation is applied downwards. M is 0.5 kilogram, G is 10 minus F equals M is 0.5. This is 200. So 0.5 is half times 10 means just 5 minus F equals, this is half times 200, that is minus 100. So just find F. I put F here, then 100 there. So F should be 5 plus 100, meaning that resistive force acting on the coconut is 105 newtons. 105 newtons. So the answer for the 13th question should be third one. Okay, moving to the 14th question. Two ends of a light inextensible string which goes over smooth pulley which is connected to fixed point attached to masses 10 kilogram, 6 kilogram. When the system is released, acceleration of 10 kilogram mass is. So it's a simple pulley question. The pulley is smooth. The masses attached to the pulley are 10 kilogram and 6 kilogram. 10 kg, 6 kg. So the weights acting on each 100 Newton and 60 Newton. Tensions at the both sides of the string should be same because it's a smooth pulley. So simply you have to apply Newton's laws to each mass. So as you can see, the system has two acceleration to this direction, meaning 6 kg has to go upwards at simple A, 10 kilograms downwards at simple A at the same acceleration. Then I'll apply Newton's laws. First to 10 kg downwards, F equals ma. So these are 100 minus tension upwards equals mass 10, acceleration simple A. First equation. Then I apply to 6 kg upwards, F equals ma. Tension upwards minus weight 60 downwards, mass 6A. Second equation. So here we have to find the acceleration. So to find that, these are simultaneous equations. Simply add the equations. So 100 minus t plus t minus 60 equals 10a plus 6a. T cancels off. 100 minus 60, 40. 40 equals 16a. So the acceleration is 40 divided by 16 meters per square second. So don't just directly divide by 16. First divide this by 4, then divide the answer again by 4. Right? So it is 16. So we divide 40 by 4, it is 10. Then if you divide again by 4, 10 divided by 4 should be 2.5 meters per square second. So this is the acceleration of the system or each object. So the answer should be first one for the 14th question. Okay, the last question of the paper is 15. An air molecule with mass 6 times 10 to the power 27 kilogram. So this is the mass of the air molecule. Is incident normal on a wall at a speed 400 meters per second and bounces off at the same speed, 400 meters per second. The air molecule hits the wall 1000 times per second. So this air molecule can hit the wall 1000 times per second, meaning that these have like very large velocities, and the space is small, so it can hit like 1000 times per second. Then they say there are 10 to the power 23 molecules in the molecules hit the wall. They say that such molecules, there are 10 to the power 23 such molecules that are having collisions with the wall. So what they ask is the average force applied on the wall due to the collision of all these molecules. So for first, I'll consider the collision of one air molecule. So here what we are going to find is the change of momentum for collision of one air molecule. So this is the case. So change of momentum, that is mv minus mu, final momentum minus initial momentum. So as you find the difference, you have to be careful about the directions. Okay, the 400 times, I'll just say the mass of this is a simple name and velocity as v. So mv to this side minus mv to other side. So if it just bounces off to the opposite direction, if you remember it's better. You just have to add the velocities. So if here for the vector calculation, if you change the direction of the arrow to the opposite direction, then you can write it with a negative sign. So this negative becomes positive. That's why those momentums gets added. So this is mv plus mv. So it is 2mv. This is the change of momentum for a one collision of the one air molecule. So I can substitute this. Mass is 6 times 10 to the power 26. 27 times velocity is 400. So if I simplify this, 2 times 6, 12, 12 times 4, 48. Then there are 2 zeros. So if we substitute it with this one, it becomes minus 25. This is 48 times minus 25, that is the change of momentum for one collision of a one air molecule. Then they say there are like 23 such collisions. So you just have to multiply this whole thing by 10 to the power 23. This is for the total momentum 48 times 25 times 23, 48 times 10 to the power minus 2 kgms minus 1. This is for change of momentum for 10 to the power 23 number of molecules. So each of those molecules hits the wall 1000 times per second. So there's per second. So if you just multiply that number by here, this converts into a change of momentum, but for a rate of change of momentum, meaning force. So to find the force, just multiply this number by thousands per second. So that 1000 is defined for 1 second, meaning this converts into a rate. So this is a rate of change of momentum, meaning this is a force. Okay, so just have to simplify this. This is 10 to the power 3, 10 to the power minus 2, then 10 times 48, 480. So there's a 480 newtons of force applied on the ball due to all these collisions of all the air molecules. So the answer for the question should be, 15th one should be 480